Okay, so composition, plug-in functions, other functions. On number one here, if we're doing f of g of x, that means which one's getting plugged into which one? G is getting plugged into f. So if we start off with f of x, this is basically what f of x looks like. X squared plus 2x. So I'm going to rewrite it as like parentheses squared plus 2 times parentheses. And inside that parentheses, I'm going to put g of x. So it looks like this. Right when we plug in the function, what's the first thing we do? Or the next thing we do, I guess?
Where's the
Before that. Check the domain. We need to look. We need to check domain right now. Because as we saw last class, we could have some restrictions. So in this example, are we taking any square roots? No. Are we dividing by x at all? No. Okay. So no domain restrictions from this. And so now we would just simplify. So now, yes, Mikey, we would square this. How do we square that right there? Oh, yeah. How do we square that? Mike.
multiply x minus 4 by on itself.
Yes. Multiply x minus 4 by itself. Do a little FOIL there. So that's x squared minus 8x plus 16. We want to distribute this too. And then we just combine like terms. And then we check the domain again. We saw last class that can have a different domain than what we saw earlier. In this case, what's our domain? Negative infinity to positive infinity. And we didn't have anything from before too, so that is our final domain for this question. Yeah. So I want you guys to go ahead and do g of f of x. Ready, set, go. All right, so when we do this, again, I like to start off with parentheses here. This one's not super difficult, but g of x looks like x minus 4, so I replace the x with parentheses, and in the parentheses, I put f of x. In this case here, like having the parentheses doesn't really do anything. So we just get to this. Whether I check the domain at the beginning or the end, we should get the same result here. What's our domain? Negative infinity and positive infinity. Yeah. We check right when we plug it in. There's no division, no square roots. We check at the end, same thing. Just to clarify, our answer to this is not just the domain. Our answer is the simplified function and the domain. Okay. Number 2 here, so we'll do f of g of x. Okay, we can see here that for the domain, like there is a denominator there. But remember in the last class, we had like denominators inside of a larger denominator. And then so we could see the smaller denominators, like we could eliminate x equaling 1/2, but then we had to simplify the rest of the larger denominator before we saw the final domain restrictions. So for this one here, like there's no other fraction in there, there's just that big bottom denominator. So right now when I look at the domain, my only thought is, okay, I just need to simplify the bottom. There's nothing else, there's no square roots, there's no other denominator inside the fraction. And so I just get to this. And so this is the result of my composition. Turn to your neighbor, what is the domain of this? Talk about it.
It's just the same as the last one.
Yeah, I dropped you.
Okay, thoughts on domain?
Yeah.
What do we think? Paula? What's that? Root 2, so x can't equal root 2. And negative root 2. Yes. That's the positive and negative root 2. So what do we want to be true as we're finding the domain of this? The bottom. Well, what do we want to be true about the bottom? Can't equal 0. So x squared minus 2 can't equal 0. We could solve this two ways. We could add 2 to both sides and take the square roots. Oops. Remember, when we take the square root of both sides, we do get a plus or minus as our answer. The other way we could do it is factoring by difference of squares. X plus root 2, x minus root 2. And to see the two zeros. But so that's everything except root 2. It's negative infinity to negative root 2. Negative root 2 to root 2. Root 2 to questions on that one? Okay, I want you guys to start the next one, plug in, start g of f of x, and find the domain. Okay, so from this first step right here, what can x not equal? X cannot equal 1, right? We've got this denominator right there of x minus 1. If we plug in 1 for x, we're going to divide by 0. Okay, so we can see that from the beginning. Now we're going to simplify this. So when I square a fraction, how do I do that again? Square the top, square the bottom, square both. Square both. Yeah, we got to square both. Okay, so we square both. We have x squared over x squared minus 2x plus 1, and then this minus 1 off to the side here. What would I need to do to continue simplifying this? Common denominator, yes. So I've got x squared over, x squared over x squared minus 2x plus 1 minus 1. And we got to multiply that 1 by x squared minus 2x plus 1 over itself. And then we need to make sure we distribute that negative sign. combine like terms. Awesome. Okay, when I'm doing domain of this, what would I need to do? Make sure that what? The bottom doesn't equal 0. Okay, so in order to do that, we need to think of the bottom as being factored. Can anyone factor this in less than half a second? X minus 1, x minus 1. How'd you know that? It's the what? It's the same as it was before. Yes, we already had this denominator. Nice. So that's what we started with, right? We started with x minus 1. X minus 1. We squared it, and we got this. And the denominator did not change. It's still the same as it always was. So we don't need to factor this at the end of the problem. We already know it's x minus 1, x minus 1. So our domain does not change once we get to the end of the problem. Fun fact, this was the answer to number 1 of the quiz last class for domain.
Oh, well, I got that wrong.
Ah, dang it. Can't win them all. Questions? All right, you guys try the next one. Do f of g of x and g of f of x. Try the domain. Ready, set, go.
Yeah, as long as we're fail.
You're not surprised by this.
All right, so f of g of x.
I don't know, but like, you can't just say everybody is equally bad.
Okay, let's take a look. Take a look. F of g of x. We do this. I plug it in. What do I need to do right after I plug it in?
Check the domain restrictions.
Okay, I check the domain restrictions. What kind of domain restrictions do we have? It can't be negative. This inside thing is not allowed to be negative because it's in a square root. So x must be greater than or equal to -1. Okay. This is why it's important that we check it at the beginning, because what happens when we keep simplifying this? What happens when we keep simplifying this? What happens next? Yeah. The square root goes away. It's going to cancel. It's just going to be x plus 1. Oh, boy. Okay. So this is f of g of x fully simplified. And so what is the domain of f of g of x? 0 to infinity? What? Negative infinity to infinity? -1 to infinity. It's the same as what we had before. That's why we have to check in the beginning, because even if it cancels out, that still must be true. If all I saw, if this was the only thing that I saw from this, my domain would be all real numbers, if that's the only thing that I saw. But that's not the only thing that we see. We see this part here where we've got square root. And so that means the inside can't be negative. Even after it's simplified, we have to keep the same domain. This is what happened last class. When we first plugged it in, we saw, ooh, okay, x cannot equal 1/2. But then we went ahead and canceled out that denominator. And we got to the end of the problem here, and it doesn't look like x can't be 1/2. It just looks like x can't be 1. But because we saw it earlier, we have to combine the two. So that's how we came up with this final domain. That's why we have to check it twice. Okay. Let's see, clear some space. For g of f of x, this one's basically fully simplified already. We can't do anything with that. That's got to stay. So again, we plug in x squared into that x right there. Domain of this. Okay, so what needs to be true if we're finding domain?
X can only be greater or equal.
What needs to be true? Big picture. Can't be negative. X squared plus 1 greater than or equal to 0. Okay, this is a parabola, so I would need to factor and then graph or do a number line test. Does this factor?
Sorry. When you try to factor, you end up getting x needs to be greater than or equal to the square root of -1, which is imaginary. And since this is a positive parabola, it's all good. We all go.
Yes. Okay. So, or another way to think of this is this parabola doesn't factor. This is a parabola shifted. It's got x squared plus 1. Which direction is it shifted? Up. If I shift the parabola up, it has no zeros. So this thing, how often is it positive? Always. This is always positive, which means the inside of this square root can never be negative, which means our domain is all real numbers. There's no x's that we need to eliminate. And if you think about it, right, if you plug in any negative number, we're just going to square it right away, and it becomes positive. So this is our answer, and so is this. Okay, let's go to the back. So we did this one already. Let me just run through the process of simplifying again. So just look at this. Just watch it happen. So we've got our x minus 2 over x, oops. F of x is x minus 2 over x minus 1. I'm going to take g of x and plug it in there. So that's x over 2x minus 1, x over 2x minus 1. I see right now I've got these denominators that aren't allowed to equal 0. So when I solve that, I get x can't equal 1/2, or we're going to divide by 0. We'll break that rule. We also have this larger denominator that is not simplified yet, but that's going to give me another domain restriction at the end. But we have to simplify first. The way that we simplify is by finding a what? Common denominator. So I'm multiplying everything by 2x minus 1 over 2x minus 1 to give it the same denominator. And then once we have the same denominator, what can we do? Cancel it out. And so on the top, I have x minus 2 parentheses 2x minus 1. On the bottom, I have x minus 1 parentheses 2x minus 1. Then I'm just going to distribute. And then I'm going to combine like terms. And that is my f of g of x fully simplified. I'm going to set the bottom equal to 0, or just think about a number that I can plug in to make the bottom 0. I see that x equals 1, or like can't equal 1. So I combine my domains. X can't equal 1/2, x can't equal 1. So my domain is negative infinity to 1/2, 1/2 to 1, 1 to infinity. Everything except 1 to 1/2. Questions on that process? All right, you guys do g of f of x. Ready, set, go. Okay, so g of f of x. We start off with x over 2x minus 1. And then I'm going to substitute in f. Okay, so when I do this, what can x not equal? Okay, what can x not equal? 1, right? 1, right? There's the denominator, x minus 1, x minus 1. We plug in 1. Bottom can't equal 0, right? Right? Okay. X cannot equal 1. Now we need to simplify. What do we do to simplify? Common denominator. We're going to multiply this by x minus 1 over x minus 1. Be careful. Don't multiply this by x minus 2 over x minus 1. It's easy to do that because the other numbers say that next to them, but you can't do that. It has to be x minus 1 over x minus 1, which is a common mistake that I see. You might have done it accidentally. Okay, so once I have common denominator, what happens? They cancel. Okay, so now on top I have x minus 2. On bottom I have 2 parentheses x minus 2 minus 1 parentheses x minus 1. So I'm just keeping that and keeping that. Then we distribute 2x minus 4 minus x plus 1. So you get x minus 2 over x minus 3. Did you get that? Okay. From here, what can x not equal? 3. So that means x cannot equal 1 and 3. So our domain needs to say that. Questions? Okay. We're gonna. Okay. So we're gonna take a second and look at functions that aren't continuous. That's just like a group of points. Remember back in the day in algebra when you first looked at functions, they just had an x and a y, an input and an output, but it wasn't like x squared or anything like that. So the domain and range are really easy. The domain is just a list of what? The x's, yeah. And the range is a list of the y values. Okay, so domain and range, very easy with these. So we can do that for both. We should list them in order. So for some of these operations here, f plus g of x, what this means is we're going to add the two functions together. This is actually a lot easier to do with kind of functions like this. So if I did f plus g of x, this would just be f of x plus g of x and we would just have those two things added together. Not a big deal. A twist could come if g of x, like say, was in a square root. What would the domain of g of x be? Zero to infinity? -1 to infinity, right? Inside can't be negative. So if that's the domain of g of x, and we change g of x, we can still add them together. Not a big deal. But the domain of the result is also -1 to infinity, right? Because we have this square root. The inside can't be negative. So what that means is that we can only add functions together for the domain that they share. So the domain that they have in common. That's going to translate to points here because that means that we can only add f and g together when they have the domain in common. So what numbers from the domain do they have in common? Like
-2
-2 and 4, which means that we can only add them together for the points that start with -2 and 4. And so we do the y's, we just add them. So for -2, we just do 1 plus 3. And for 4, we just do 7 plus -2, which is 5. We can't add them to the other points because they don't share that domain. Our domain, of course, would be the domain that they share. And our range would be the results of adding them together. So same thing when we subtract them. We can only subtract them for -2 and 4. Because that's the domain that they have in common. And so we would do 1 minus 3, which is -2, and we would do 7 minus -3, which would be 9. Okay, I want to focus on composition, because composition's the title of this standard, and it's a little bit hard. So when I'm looking at f of g of x, of these two functions, f and g, which one is x going into when I say f of g of x? Which one? Which one is x going into? So, yeah, x is going into g, right? And then g is going into f. So what we're going to use is we're going to get the x's from g. We're going to use those. And then plug the y from g into f to get the y from f. So it's plug x into g, take the result, plug that into f. So for g of x, my first x here is -2. What's the output when I plug in -2 from g of x? It would be 3. That's our output. We take 3 and we plug it into f of x. What do we get when we plug 3 into f of x? We get 2 as a result. So our point is the x from g and the y from f. What's the next x that we would use? It would be 5. See how that's the next x? When we plug in 5, what do we get from g? We get 1. See how that number is right next to the 5? We're going to take that and we're going to plug it into f. What do we get as a result when we plug in 1? gets 0. So my point is the x from G and the y from F. What would be the next x that I plug in? 4, yeah. What would our output be from G? -2. We would then take -2 and do what with it? Plug it into F, and what do we get when we do that? 1. So our point is the x from G and the y from F. Okay. What would be the next x that we plug in? It would be 0. That's the only one left. What would be our final output when we plug in 0? Seven. We get 4 as a result. We take that 4, we plug it in up here, and we get y as our 7. It's not going to go as smoothly when we go the other way. So if we plug in -2 for x here, we get 1 as a result. There is no place to plug in 1 in g of x that's not in the domain. So we can't do it. When we take 1 and plug it in and get 0 as an output, that one does go in, so we have the point 1,4. But that's the only one that works.